Hello children. In our previous video, we have studied the nature of image formed in a plane mirror. Today we'll start a new topic, that is spherical mirrors. Okay? So it is spherical mirrors. We'll study spherical mirror and the types of spherical mirror which is in our course, that is in 10th class. So let's begin. What are spherical mirrors? Let's see. Spherical came from a word sphere, and to tell you about a sphere, you can take an example of a ball. Ball is a sphere. Okay, ball is spherical in shape. We can take example of a ball. Okay, ball that the children used to play. Now let's have a ball which is hollow from inside and made up of glass. So we are having a ball which is hollow from inside and made up of glass. Okay, and at the same time I am having a glass cutter also. So with the help of a glass cutter, this is a sphere. Okay, this is a spherical ball. It is a spherical it is SPHERICAL, spherical ball. Okay. Now, with the help of a cutter, I cut this ball into two pieces and then I have removed this larger piece. Okay. So, I am now having a small piece of that curved ball. Okay, spherical ball. So, I am having only this much piece. So, this is of glass only. Now, after that, after cutting, I started polishing it from one side. So, I have polished it from outside. Okay. Now, as this glass piece is being polished from one side, now it will be a reflecting surface. So, this is the polished surface. It means the side on its opposite side of it will be a reflecting surface. So it means, what do you mean by reflecting surface? Means if a light falls on this surface, it will reflect back in the same medium. It will not allow it to pass through it because now it's a polished surface. Okay. So if any light will come and fall on this mirror, now it's a mirror, a polished surface, and a glass which is a polished one is a mirror. having two pieces now. This is one and another one I have kept it like this. Okay. These are the two curved pieces, and now I have glass pieces, and now I have to turn it into a polished surface. And if I have to turn it into a polished surface, I have to polish it from any of its surface, either from outside or from inside. Okay. So now my task is to polish it, and thus I have employed two workers and given each piece to the worker and told them to polish it. Okay. What they did, I haven't told from which side they have to polish. So what they did, one of the worker polished it from outside, right? And the other one, he has polished it from inside. Okay, see the polishing in the two pieces. See the polishing in two pieces. This is also a part of a sphere. This is also a part of a sphere. I have taken small pieces of that, and then I employed a person to polish it, and the one did it from its outer surface and the one did it from its inner surface. Both are polished ones, so both will be a reflecting surface, but they will not be of same type. Why? Because here the outer surface is polished, here the inner surface is polished. So the way they reflect the light will be quite different from each other, right? Now see this. If a light falls on this one, if a light falls on this one, okay, this will also reflect light, this will also reflect light, and if a light falls on this one, this too will reflect light. But if we see the pattern in the pattern in which they are reflecting light in the two mirrors, they will be quite different from each other, and thus the two, although is a polished surface, but as they are polished in a different way, on a different surface they are polished, so they both will be a mirror, both will be a spherical mirror, but both will be different. Okay, so these are the two types of mirror that we have to read in class 10, okay, in science. Now we'll name such mirror, means a piece of mirror which is taken from a sphere and polished from its outer surface. Such a curved piece of mirror is said to be a concave mirror. So this mirror is named as a concave mirror, and this one is named as a convex mirror. So what is concave mirror? It's a curved mirror, which is a part of a sphere. It's a curved mirror which has its outer surface polished, and the inner surface acts as a reflecting surface. And here a piece of a curved mirror whose inner side is highly polished and the outer surface acts as a reflecting surface. Such a mirror is called as convex mirror. Okay, so this is a concave mirror and this one is a convex mirror. Now let's see the different terms we used when we next we have to study the rules. Okay, the rules that a light follows when it falls on a mirror. What are the various rules it follows? Okay, so to study rules even we should know first some of the terms. Okay, so in this video we'll just come across some of the terms that we use, okay, while making images of an object or while studying images, how the image gets formed. We have to come across some terms. So let's complete that one. Okay, so this is a curvature part. This is a curvature part of a mirror. Okay, this is the curvature part of a mirror. So from this point to this point, the distance between these 2 points is called aperture. That is called aperture. Okay, and this is the curvature part of a mirror. This is a curvature part. This piece is a curvature part of a mirror. Okay, now the points now. The first point we have to see is pole. So what is pole? Okay, what is pole? Pole is the actual center of this curvature part of a mirror. This is the curvature part of a mirror. And this curvature part has some point which is the center point of it. Okay. The center point of this curvature point is called as pole. And it is noted by capital P. Pole it is. So pole is noted by capital P. Okay. And how will you define it? It is the actual center of the curvature part of a mirror. Okay, let's see. This is also a curved mirror. This is a spherical mirror, or you can call it curved mirror. It's a convex one. This we have studied. Okay. Now this curvature part has some center. Okay. So let this be the center of this curvature part. Okay. This point, this is equal to this curvature. This is the center of this curvature mirror, and this point is called as pole. This point is called as pole. Okay. So pole is clear. It's denoted by capital P. Okay. Now, what else? I told you that these curved mirrors, they are the part of some sphere. Okay. So this is also a part of a sphere. Okay. Now, this sphere is also having a center. Okay. The actual center of this sphere of which this mirror is a part, the actual center of the sphere of which this mirror is a part, that is called as center of curvature, and it's denoted by capital C. So what is center of curvature? What is center of curvature? Okay. What is center of curvature? It's denoted by capital C. It's denoted by capital C. But what actually it is? It is the actual center of the sphere of which this mirror is a part. ये उस स्फेयर का सेंटर है जिसका ये मिरर एक पार्ट है. ओके, उसका एक हिस्सा है. उस एक्चुअल स्फेयर का जो सेंटर होता है, that is also a center of curvature of center of this curvature piece. Center of this curvature piece. उसका भी सेंटर, इस कर्वेचर का भी सेंटर वही होगा जो उस स्फेयर का होगा, जो कि है ना, जिससे हमने ये बनाया है. राइट. सो व्हाट इज सेंटर ऑफ कर्वेचर? इट इज अ सेंटर of a sphere of which this mirror is a part. Okay. This piece also, this curvature piece also is a part of some sphere, is also a part of some sphere. Okay. And this sphere will, and let the center of this sphere be this one. Okay. Center of this sphere is this one. So this point C is also a center of this curvature piece. Okay. It is the center of this curvature piece also. So center of curvature is the actual center of the sphere of which this mirror is a part. So that is center of curvature. Then if you join these two lines, if you join these 2 points, okay, I've made a line which is passing through both the points P and C. Such a line is called as principal axis. Such a line is called as principal axis. So what is principal axis? It's an imaginary line that I had drawn passing through both the points. Okay, passing through both the points C and P, and such a line is called as principal axis. So what is principal axis? Okay, what is principal axis? It is an imaginary line passing through both C and P. Okay. Now, the next one. If I'll say radius of curvature, how will you define radius of curvature? Radius of curvature. Okay. Radius of curvature is denoted by small r. In some of the books, it may be written capital R, doesn't matter. Radius of curvature is, you can take it, I am taking here small r, right? Now, what is radius? What is radius? Radius is, if I will draw any circle, and if this is the center point of this circle, so any line passing through this and joining to any point on a circle is a radius. Okay, this is a radius of a circle. This is a radius of a circle. Same way, this curvature piece, this curved mirror, है ना, इसका भी radius of curvature क्या है? What is the radius of curvature of this? So any point on this, है ना, any point on this curvature part if joined to this center of curvature will be a radius. Will be its radius. अगर मैं यहाँ join करती हूँ, this is also radius. Okay. But we are specifically taking which one as a which one considering here? Well, I am considering this point. Means if I see the distance between C and P, the distance between C and P is also a radius. It's also a radius. है ना? I had joined C to any point P on a this curvature piece. So the distance between this will be a radius, and it is a radius of this curvature piece. That's why it is called radius of curvature. Okay, so this is radius of curvature which I have denoted by small r. Okay, now, so this radius of curvature is a distance and center of curvature is a point. Center of curvature is a point and radius of curvature is a length. It is a distance. Okay, the distance between C and P, you can say simply, you can say the distance between C and P, or it is the radius of this curvature part. This is also a radius, but we are considering this one. Okay, C and P, distance between C and P is a radius of curvature here. Okay, now the next one is, what is focus? Focus is what? Next point, fifth point is focus. F-O-C-U-S, and focal length. Together we'll see what do you mean by focus and what do you mean by focal length. Again, focus is a point and focal length is a distance. Okay, focus is a point and it is denoted by capital F, and focal length is it's a distance and it is denoted by small f. It is denoted by small f. But what actually they are? Let's see in our figure what actually they are. So see, focus, we have to say focus is a point. Focus is a point on a principal axis. Where it lies? It lies on the principal axis. And what is principal axis? It's an imaginary line passing through C and P. On that line on which C and P lies. So F is also on this line only. F is also on this line, but actually what it is? It is that point on a principal axis. It is that point on a principal axis from where all the parallel rays after reflection passes. Okay. If I'll make 3 or 4 lines parallel to principal axis to fall on a mirror, okay, I had drawn 3 lines parallel to principal axis that falls on a mirror. What will happen? We'll see that the parallel lines after reflection will pass through one point, same point they will pass through, and that common point is called as F. That point is called as focus. So what is focus? Focus is a point on a principal axis from where all the parallel rays after reflection passes through. That point is called as focus. Okay, let's see what is focus here. So this, if I join these 2 lines, it will be a principal axis. This will be a principal axis, and the distance between P and C will be radius of curvature. This distance is called as radius of curvature. Now, what is focus? If I'll make 2 or 3 rays parallel to principal axis to fall on a mirror, after reflection it seems to diverge from some point inside. In this case it seems to diverge, and in this case it actually meets. Okay, so we'll see that the rays will diverge, and the rays are diverging from some point inside. The rays are diverging from some point inside. Okay, this is the way they are diverging. This is a reflecting surface, this is a reflecting ray, this is a reflecting ray, and as they are diverting to where they will meet. They will meet if I'll extend it in the backward direction. If I'll extend them in the backward direction, and if I'll extend it, they will meet at a point, and that point will be a focus. So focus is that point here in this mirror. Focus is a point on a principal axis. If this, see this is on a principal axis. It's that point from where all the parallel rays after reflection seems to diverge. It is that point from where the reflecting surface seems to diverge. Reflecting lights है ना, जो light है वो किसी एक point से divert हो रही है. वो point जो हम extend करके बना रहे हैं, that is called as, will meet at a point, and that point is called as focus. Okay, so what is focus? Focus is in this mirror. Okay, together we'll see what is focus. It's a point on a principal axis where all the parallel rays after reflection actually meets or seems to diverge from some point inside. In this mirror, and actually meets in this mirror. So together we can say it's a point on principal axis from where all the parallel rays after reflection actually meets or seems to diverge from some point inside. and that point is called as principal, that point is called as focus. Okay, that point is called as focus. Now what is focal length? Focal length is again a distance. Now as radius of curvature was distance between C and P, the same way focal length is distance between F and P. So F and P, distance between F and P is a focal length, and distance between C and P is the radius of curvature. Okay, and it has been found that this distance is this point is always a midpoint of this one. Okay, this point is a midpoint of P and C. Okay, so if I'll ask what is the relationship between R and F? What is the relationship between R and F? Okay, what is R? Radius of curvature. What is F? Focal length. And I said F is the midpoint of this sentence. What's the relationship? The relationship is that R is 2 times F, or you can say F is R by 2. Okay, so they can ask you a curvature mirror, means a curved mirror has a focal length of 8 centimeter. What will be its radius of curvature? Actually, it will be twice of that. So radius of curvature will be 8 to the 16. Or they may say that a focal length of a mirror is 36. What will be its radius of curvature, or whatever. Okay? So any one of the two will be given, and you will be asked the other one, what is the value of the other one. So you should know the relationship between the two, that this R is 2 times F, or F is R by 2. So you can easily find it out what's the value of other one if one is given there. Okay, so in today's video we have learned what a spherical mirror is, then what are the types of spherical mirror. So we have studied 2 types of spherical mirror, concave and convex, and then what are the various terms we use while we draw or while we study the reflection through it or formation of image in a spherical mirror. What are the various points that we go through? And these are, first we should know what a pole is in a curved mirror, what a pole is. Then what is a center of curvature? When we say the line passes through center of curvature, so what does it mean? What is actually center of curvature is? And what a principal axis means? And then what is radius of curvature and how it is denoted? And then focus and focal length. So we have gone through all these points, and in our next video we'll see the rules that we use while making the image of any object. To get an image of any object, what rules we have to follow there, so that we will study in our next video. By that time, I go through this and try to understand this, and hope this will be clear to you. Okay, bye.